Another useful concept which is used in the classical mechanics is the impulse. So here we will be dealing with the concept called as the impulse, because in second law of motion we from Newton's laws we can calculate the force. But suppose sometimes we encounter some examples under which we have got a lot of high amplitude forces. That means high value forces, high value or forces are acting for a shorter period of time, okay? So that means F is very much higher, but the duration for which the force is acting, it's very much lower, it's very much smaller, okay? This indicates these two conditions. So when such a case arises, we say that the impulse is generated onto that body upon which force is acted. Say for example, here is the wall, rigid wall, and I throw a ball onto it, okay? It is moving with the velocity v, but here when the ball strikes onto this wall, it stays with this wall for a very small period of time, very small period of time. But the force acted onto this wall is very much high, so the period of time is so much minute that we can't calculate accurately the force generated by the body onto this wall, or force applied by this ball onto this wall, okay? So in that case, force is very much higher, but the period of time for which the force is acted onto the wall is very much lower. But the product of these two, product of force and the time for which it is acting onto it, that is time of action, we can say time of action. This product of force and time, it is also called the change in the momentum. We can change in the momentum. I will show you how it is equal to the change of momentum. And this term, the product of force and time, this remains finite, still finite, remains finite, and it can be calculated, okay? It is possible to calculate. But for force is very much huge. So it's like this. Suppose with respect to time, this is the time axis, a force is generated at some particular instant of time. Say for this period of time, this is the delta t, but first force is 0 and after the effect of force is 0, fine. But when it reaches at this point, force becomes so much, it takes its peak values, fine. So there is like a peak seen in the graph, okay? So that means at this instant of time, there is a huge amount of force applied onto this wall, and this is called as the impulse. Because you might be well aware about the concept of impulse. Impulse means something which has got a very much high amplitude, okay? Similar case happens with the forces, okay? Fine. So how to calculate this very thing? How to solve this very problem? Here comes the concept of impulse. So impulse, even though force is very much huge, time is very much small for which it is applied, so time of action is very much smaller, but the product of these force and time is still finite and is still calculable, okay? It can be calculated, fine. So this is equal to the change in the momentum. How that is, I will show you here. I have told you this is the impulse. Impulse is equal to the force, and here this is the called as the impulse, okay? Impulse is equal to force multiplied by the time of action. time of action. So that means I represented by impulse represented by I is equal to the force multiplied by time of action. Fine. And we know from the second law of motion, what is the second law of motion? Second law of Newton, second law says that the force is directly proportional to the rate of change of the momentum is directly proportional to force applied. So that means force is equal to the rate of change of momentum with respect to time, which is the second law of motion. Second law. Fine. So that means upon substituting here, we get I is equal to F is substituted by this, so we will get delta P divided by delta T multiplied by delta T. This and this goes roughly, I'm saying. It is not exact case because it is twisted mathematics done here. So for that, I will be equal to delta P. This is what I was telling you earlier, that the product of force and time of action is equal to the change of momentum. So we can calculate the change of momentum. From that, we can calculate the impulse. Fine. So for that, we will solve an example. We'll get clarified further by solving an example. Say, for example, there is a batsman. Here is a batsman with a bat inside his hand. So a bowler here throws a ball towards him. A bowler throws a ball towards him. Say, for example, we are getting this is positive direction of x-axis and this is the negative direction. So ball is thrown like this and this batsman hits it back. Say the initial velocity of the ball is 12 meters per second. Say initial velocity, so u is equal to 12 meters per second, and the batsman pushes it back with the same velocity, so final velocity is also 12 meters per second. But we had taken, since we have, it is just the supposition, we can take positive direction in this case also, in this direction also. Okay, it is just for convenience we are taking it in. So I have told you that the bowler is pushing the ball with a velocity of 12 meters and the batsman is pushing it back with the velocity, same velocity, but in the opposite direction. So in that case, u will be minus time because we are taking the positive direction in this direction here, just for convenience. Okay, so we have to calculate the impulse generated because force acted onto the body, it's for very much smaller period of time, so time of action is very much smaller, so it is not feasible to calculate the force. So we calculate the product of force and time of action. Okay, so that is the impulse, and we know if we are not given the time of action here, we can still calculate the impulse because we know how to calculate impulse. Impulse is just equal to the, as earlier told you, that it is just equal to the change of momentum. Okay, so how to calculate the momentum? We know from formula, we know that momentum is equal to mass times velocity. Okay, so what will be the initial velocity, initial momentum? Pi initial. Okay, that will be mass is 0.415 kg multiplied by velocity. What is the initial velocity? Is 12, but it's minus times 12, minus 12 meters per second. Fine, and the final momentum will be equal to 0.15 kg into the velocity. Velocity is still 12, but in the positive direction. Okay, that's v. Okay, that's fine. So in both the cases, it is here minus 3.6 newtons. Sorry, what I calculated? Sorry. So we'll get here the initial momentum like this and the final momentum like this. Fine. So now impulse, from here we can calculate impulse is equal to the change in the momentum, and we know change in the momentum is v final minus p initial, and that will be equal to v final will be this much this much, and P initial will be this much, and both are, this is minus, this is plus. So this is this much of quantity minus times this much quantity, but this is also minus, so minus minus becomes plus. So this will be 0.15 kg. I will not use the units. 1.5 into 12 meters per second into 0 decimal plus here, okay, it will be plus times 0.15 into 12 meters. This is the initial velocity in the negative direction, and negative negative becomes positive here. So on calculating, we'll get something Newtons second, something Newton second, and this Newton second is the units of impulse. Units of impulse. How to calculate that? We know that impulse is equal to the force, product of force, and the time of action. Time of action. What is the units of force? It's Newton. And what is the time of action? Time units has units second. So that's the units of I is equal to Newton second. That's as simple as it is. Fine. So this was all about the impulse. Fine. Hope you got that. I'll see you in the next.